Today we are going to be doing the notes for 6.1, which are mid-segments of triangles. Our goal for today is to learn and use properties of mid-segments of a triangle. So we keep saying this word mid-segment. What is it? It's going to be a segment that connects the midpoints of two sides of a triangle. So let me show you. Draw a triangle here. There's a triangle. Now if I take and let's say here's the midpoint, mark the midpoint by marking those two sides congruent, and let's say this is a midpoint of this side, the mid-segment is going to be this segment that connects those two midpoints right there. So we'll call this point A, this point B, and segment AB is the mid-segment, or is a mid-segment, I should say. Of the triangle. So we can actually go in, we'll define this now as well. So a mid-segment is a segment connecting the midpoints of two sides of a triangle. The three mid-segments conjecture. This says that if we find the midpoints of all three sides, so here's a midpoint, here's a midpoint, here's a midpoint, and now what we can do is we can connect all these midpoints. So here's your first mid-segment, here's another mid-segment, and here's another mid-segment. And what this is, this conjecture is, it says that the three mid-segments of a triangle is going to divide the triangle into four congruent triangles. You could do it shorthand too. So that means if we're looking at this, here is a one dash, a double dash. This one has to be a triple dash. And then in this one, you have a double dash, a triple dash. This one must be the single dash. And here's your your single dash, triple dash. That means this has to be the double dash. And so then what you can notice is you have 1, 2, 3, 4, or 1, 2, 3, 4 congruent triangles that are made up in this triangle. You can also see that this mid-segment here is half the length of this full side, which we're going to get to in just a minute. The triangle mid-segment conjecture says a mid-segment of a triangle is parallel to the third side and half the length of the third side. So as I was saying, let me find those midpoints. There we go. Now, this line right here, oops, and this line that goes through the bottom, these two lines are going to be parallel, okay? We also know that if we marked the midpoint on this side, this part and this part would be congruent, and this mid segment is that same length as half of the side that it's parallel to. Okay, so this mid segment is parallel to this side of the triangle, and then it's also half the length of this whole side. So where the midpoint is, that's going to cut this segment in half. So half of this is the same length as that. So that is how we get this half. That's how we also can see that these 4 triangles are congruent up here based on that being half the size. And what we would label up here, you would then see all 4 of those congruent triangles. So moving on to the next page here, what you can do is I like to label if you are going from 20 to the smaller mid segment, you're going to divide by 2, you're cutting in half. But if you're going from the mid segment to the larger side, you would then multiply by 2. So if it's cutting in half or doubling, it's either going to divide by 2 or multiply by 2. So that's kind of your rule. So here you can figure out what x is. Since you have 20, you know that in order to find x, we're going to have to divide by 2. So x here will be 10. I always like to label it in my diagram. Also, you'll notice that anything with 1 dash is going to be the same. So if that's 9, then this also has to be 9. And if z is labeled here and 12 is labeled with the double dashes, z has to be a double dash, which is 12. So there we can figure out that one. Now this next one, again, it might help if you actually label, if we are going smaller, we're going to divide by 2. If we're going to go bigger, we're going to multiply by 2. So we know that this entire side has to be the length of 10, but it's being represented by x plus 3. So then when we solve that, we're going to get x plus 3 equals 10. Subtract 3 on both sides, we're going to find that x is 7. Then again, just like last time, anything with a double dash has to be 12, so z will be 12. Anything with a single dash has to be 10, so this y has to be 10. Identify the parallel segments in each diagram. So, starting with this segment here is parallel to this segment here. They're going to appear to be parallel if it is drawn to accuracy, so then we're just going to write this. This segment NL is going to be parallel to segment AC. All right, I'll change colors on us now. So LM, this segment here, is parallel to this segment over here. So segment LM is parallel to segment BA. And a third color, this last mid-segment here, will be parallel to this side here. So the mid-segment is NM, is going to be parallel to BC. And there we've identified all 3 mid-segments and which segment in the triangle they are parallel to. Identify the length of each segment. So here if we label AC is 10, so this whole side is 10. AB is 8, so this whole side is 8. BL, which is only this section right here, is 3. So then we have to go and we have to identify all the segments on this diagram. Well, if that has a double dash, that 3, then this one has to be 3 over here too. And you know then that if this whole side is 6, this mid-segment here is half of it. So it also is going to be 3. We can use this 8 to label half of that is 4 and 4. And if half of it is 4, that's also going to match the mid-segment. Now this whole segment AC is labeled 10, the green one. So if we cut it in half, each half is going to be 5, which also shows us what that mid-segment will be. And that's how we label all the segments. If you have any questions, let me know.